page 2 of differential calculus. We're going to talk more about limits here, some more details, especially if you will be doing advanced math in college. Okay, so first let's look at this notation here. If we want to talk in particular about horizontal asymptotes, basically horizontal asymptotes are what happens on the far right or the far left when the x value is very big or when the x value is very negative. So if we want to go infinitely to the right, we would say x is approaching infinity, and if we want to go infinitely to the left, we would say as x approaches negative infinity. Okay, so those are the two mathematical phrases we use to indicate whether we want to go to the right side or the left side. Horizontal asymptotes occur when a function converges to a finite value even as x approaches an extreme infinite value. Okay, so even though, like, look at our old friend the rational function. Even though we're going infinitely to the right, the curve goes down and down until it gets very, very close to the horizontal line y equals 2, even though it never touches. That's an asymptote, right? Then we can also use the rational function to talk about the vertical asymptote. So here's the vertical asymptote, which is a vertical line at x equals 4. This rational function has very extreme behavior when we get close to x equals 4. And in one case, coming from the left side, notice how the rational function, as we get closer, goes down to negative infinity. And from the right side, it goes up to positive infinity. So it's like, depending on if you're coming from the left side or right side, it behaves very differently. There's a math notation we can use to talk about the approaching the vertical asymptote from the left or the right side. It's this little negative sign on the top right of the number, or the positive sign on the top right of the number. So the negative sign on the top right of the number means you're approaching it from the left, and then the positive sign on the top right is from the right. And notice it's in the top right. So usually we use the top right for exponents. In this case, we're going to use it to signify if we're approaching from the left or the right. Okay? All right. So what happens when we approach x equals 4 from the left? Remember, we said it goes down very far, so it goes to y equals negative infinity, or in this case, f of x approaches negative infinity, right? As we approach x equals 4 from the right side, we're going to go up. We're going to go to positive infinity. So you could just write infinity, or you could write positive infinity. In both extremes, the function approaches the value 2, but from below or above. So when we're going to go very far to the right or very far to the left, notice it goes toward the y value 2. In the case of going far to the right, look at it's coming from the top. And when we're going to the left, it approaches it from the bottom. So how do we signify that? So let's say, we're going to the left here. When we're going to the left, notice that it approaches from the bottom. It approaches 2 from the bottom. So we say 2 from the bottom. So do you see how the negative in the top right corner is indicating this case from the bottom? Here it indicates from the left, and here indicates from the bottom. Okay, so if it's a y value, it's top and bottom, and if it's an x value, it's negative, it's left and right. So when we're going to the far right side, or positive infinity, then we're approaching from the top. See, we're approaching from the top. So then we would put 2 and then positive in the top right corner. Okay, so that's how that notation works. This notation is not going to be on the IB exam for SL. But it might be something that you use in your IA, or it might be something that you will encounter in future math courses. For each of the following functions, discuss the behavior near the asymptotes and hence deduce their equations, state the values of the limit of the function as we approach negative infinity, x equals negative, x is negative infinity, or x is positive infinity. So that means we want to know what happens when we go very far to the left or very far to the right. Okay, so let's look at A first. Oh, it's the rational function, and it's the rational function located with its center at the origin. Okay, so in this particular case, the behavior near the asymptotes, let's see. So the asymptotes in a rational function are, there's one horizontal and one vertical. Since this rational function is centered at 0, 0, the two asymptotes are x equals 0, that would be the vertical asymptote, and the horizontal asymptote would be y equals 0. Okay, and we are going to approach the vertical asymptote of x equals 0 in two different ways. One of the ways would be up here, and one of the ways would be down here. Okay, so when, let's see, if we approach x, if we approach 0 from the left, then we see that we are going to go down. So that would be negative infinity, right? Okay, and then if we approach 0 from the right, then the function is going to approach positive infinity. You just write in infinity. Okay, let's talk about the behavior of the horizontal asymptote. If we approach x is negative infinity, that would be over here, we're going to approach the horizontal asymptote of y equals 0 from the bottom. 0 from the bottom. And if we approach over here, x approaches positive infinity, far to the right, then we are going to approach 0 from the top, right? Okay, so that's that one. Let's do C. Okay, so for this one, this is also our old friend, the rational function. Remember this one from chapter 2. We can analyze it using Shinovato Abonlisho, right? So where are the vertical asymptote and horizontal asymptote here? So the vertical asymptote would be when the denominator is 0. This denominator is 0 when x equals negative 2/3, right? If x is negative 2/3, then this will perfectly add up to 0. So this would be the vertical asymptote, right? And the horizontal asymptote for this is when you put a big number in here. So let's see, if I put a big number in the top and the bottom, I would end up with something like negative 2/3, because it would be negative 2 billion divided by 3 billion. So that would be negative 2/3. Oops. Y equals negative 2/3. Okay, so that's my horizontal asymptote. That's my vertical asymptote. Let's talk about the how we would write the limits in this case. So we're going to put for the vertical asymptote, we're going to say, okay, as we approach the vertical asymptote from the left, so as we approach negative 2/3 from the left, would we be going up or would be going down? In order to see that, let's graph it. Okay, so here is my graph. And so as I approach the vertical asymptote from the left, you can see that it goes down. So I would set this equal to negative infinity, right? And then as I approach let's see, x is negative 2/3 from the right, what happens then? If I approach from the right, you see it goes to positive infinity. Okay, so those are the two limit statements that I made for the vertical asymptote. For the horizontal asymptote, what a coincidence, the horizontal asymptote is also negative 2/3. In the horizontal asymptote case, if I was to go to the right, which would be the limit as x approaches positive infinity, f of x would equal negative 2/3, and I'm approaching from the top or the bottom? I'm approaching from the top, right? So that would be a positive in the top right corner. And then finally, if I approach x is negative infinity, then I would be approaching the left side, so I would be coming from the bottom. I would put negative 2/3, and then I would put a negative sign in the top. Okay, and let's see, let's go to the next one. Sketch the graph of y equals e to the x minus 6. Okay, so let's do that. Remember that e to the x we can graph in the following way. Just e to the x with no minus 6 would be 0, 1, and 1, 2.7, right? And then if I was going to translate it down by 6, then it would become 1 minus 6 is negative 5, and 2.7 minus 6 would be negative 3.3. Okay, so let's graph that. Oh, and by the way, the asymptote of e to the x would be y equals 0, and the asymptote of e to the x minus 6 would be y equals negative 6. Okay, so let's draw the asymptote at y equals negative 6, negative 5, negative 4, negative 3, negative 2, negative 1, and then this would be the horizontal asymptote, and this would be the vertical asymptote, and then our function would be 0, negative 5, and 1, negative 3.3. And then it would approach the asymptote. Something like that. Okay, so let's answer these questions now. So first it says, what is the limit as x approaches negative infinity? So that is going to the left of this function. Looks like it's approaching the asymptote of y equals negative 6, right? So I'm just going to put negative 6. And then it says, what happens with this function as I go to the right? X approaches infinity, positive infinity. And you can see that basically I didn't draw it very well here because I don't even know any of these values, but it obviously goes to infinity. So here I could say it approaches positive infinity. I can just say infinity. Okay, so that's it for this page.